We are back on ExamDost. We are back with the rank improvement cum crash course for power electronics. So quickly, everybody join. Come on, come on, come on, everyone. जल्दी से फटाफट आ जाइए भाई सभी लोग. Today we are going to discuss the PYQs on the first two unit. That is the first is the semiconductor devices and the second is your rectifiers. Okay. So semiconductor devices and the rectifiers we are going to cover. चलिए जल्दी से quickly everybody join. चलिए. So let me start the first question. The triggering circuit of a thyristor is shown. It requires a current of 10 milliampere for guaranteed turn on. What is the value of R required for thyristor to reliably turn on? चलिए जल्दी से बनाइए भाई. Come on everybody. जेईई की 100 क्वेश्चंस की सीरीज होगी क्या यार? उसके लिए मतलब कुछ खास बच्चों का रिस्पांस आया नहीं, तो इसलिए मैं अभी तक प्लान किया भी नहीं. मैंने जैसे और भी वीडियो डाले जेई के बारे में, बट किसी पे भी बच्चों का कुछ खास क्वेरी आ ही नहीं रहा है. अभी मेरे को लग नहीं रहा है कि एसएससी जेई वाले बच्चे बहुत सीरियसली अभी इस समय पे ना यूट्यूब अटेंड कर रहे हैं. चलो राहुल भाई बहुत बढ़िया. आओ भाई. तो देखिए यार, आई विल सॉल्व फॉर वर्स्ट केस. I will say minimum gate current is 10 milliampere. For which I will take minimum value of the supply voltage. Okay. Answer will be 800 ohm. Very simple. I will take the minimum supply voltage. So what am I saying? Even with the minimum input, my thyristor is able to trigger. Okay. This we had already done beta. ये हम लोगों ने कर लिया था ना. Okay. चलिए try this one. This is a very beautiful question. Try this everybody. चलो चलो चलो. देखिए भाई, अब 1:1 pulse transformer is used to trigger the SCR. In the adjacent figure, SCR is rated 1.5 kV, 250 ampere. Latching and the holding current is given. Maximum and the minimum gate current is given. The load is the inductor in series with a resistor. Okay. Supply voltage is 200 volt DC. Forward voltage drop is given as 1 volt. Now I need to know the resistance required to trigger the SCR. So see this. Now, beta, when we want to trigger, my BJT should be on. Why BJT should be on? So that current can flow. So the drop across BJT will be 1 volt. It has told in the on state, the voltage drop should be 1. Okay. So during this time, the BJT will be on. There will be a drop of 1 volt. So across the winding, you will have 9 volt. Now it is 1:1. So I get 9 here. Now across the diode, there is a drop of 1. So here I have 8. Between gate and cathode, it has mentioned gate, cathode, transistor, diode, 1 volt. So basically, resistor is 7 volt. Now 7 by R should be greater than equal to the minimum gate current, and 7 by R should be less than equal to the maximum gate current. Now minimum gate current is how much? 100. Maximum is 150. So R less than equal to 70 ohm. R greater than equal to 47 ohm. So between 47 and 70 it should be, तो answer should be 47. ठीक है, मेरे पास जो वैल्यू आ रही है that should be 47. The next part of the same question is the minimum approximate volt second rating. What is the volt second rating, beta? The voltage multiplied by the minimum pulse width required for triggering. You have to multiply the voltage by the minimum pulse width. वोल्टेज से क्या मल्टीप्लाई करोगे? मिनिमम पल्स विड्थ. करिए. So try to find the minimum pulse width beta for this circuit. कौन से वाला बता दूं बेटा? कौन से क्वेश्चन में डाउट आ रहा है सुमुखा जी? यहां पे 10 वोल्ट है. एससीआर को ऑन करने के लिए बीजेटी ऑन. यहां 1 वोल्ट का ड्रॉप आया तो यहां पे 9. 1:1 से यहां पे 9. ये डायोड ऑन हुआ, 1 वोल्ट का ड्रॉप आया तो यहां पे 8. गेट कैथोड पे यहां पे 1 वोल्ट का ड्रॉप, क्योंकि लिखा है बेटा गेट कैथोड पे भी 1. तो इधर 8 आ गया, इधर 1 आ गया, तो रेजिस्टेंस का वोल्टेज हुआ 7. और रेजिस्टेंस से क्या जाएगा? गेट करंट. तो वोल्टेज अपॉन रेजिस्टेंस इक्वल टू IG. सिंपल. देखिए भाई, तो मिनिमम पल्स विड्थ अपने को जानना है. See this. This L is given to me as how much? 150 millihenry. So for minimum pulse width, you have to check the current. R by L. So I equal to I latching. How much is the latching current? 250 milliampere. So what is the value of T? T कितना आएगा? (187.6 microsecond). The voltage of supply is 10 volt. (1876). Okay, 1876. The closest answer is 2000. ठीक है? Applied voltage is 10 volt. जो क्वेश्चन था उसमें V और I की वैल्यू डिफरेंट है, क्या बोल रहे हो? ये ट्राई करो. A SCR is considered to be a semi-controlled device because why do you consider the SCR as a semi-controlled device? बताइए भाई. Why do you consider SCR as a semi-controlled device? Because it can be turned off but not off with a gate pulse. Very good. Next, beta, you need to match the steady state operating point. I have given you the crosses. Match the switch with the characteristic. ठीक है? Match the switch with the corresponding characteristic. चलो भाई बताओ जल्दी से. देखें भाई. So first is a diode. For diode, positive current and negative voltage. This is for diode. Then SCR, bipolar and unidirectional. Then IGBT. And this is the, because of the anti-parallel diode, it will be bidirectional. So for A, it is 4. For B, it is 3. For C, it is 1. So 4, 3, 1, 2. Answer will be C. Next, beta, this we have already done. कुछ क्वेश्चन देखो PYQ के ऐसे होंगे जो हम क्लास में कर चुके हैं. चलिए ये वाला बताइए, ये हमने किया था? ये मेरे ख्याल से नहीं किया था, ये ट्राई कीजिए. इट इज बेस्ड ऑन LC ऑसिलेटर. देखें भाई, LC circuit has inductance, capacitance, initial capacitor voltage is 100. तो देखिए, whenever initial voltage is given, the voltage will follow the cosine curve, current will follow sine. So answer will be omega naught is 1 by root LC. Okay. Now I am connecting this question to one more circuit. This is my circuit. So the question is the LC circuit. Okay. Now the initial value of L and C. Okay. The switch is closed at t equal to 0. What is the time taken by the device to turn off? अब ध्यान से सुनिएगा. This is how the capacitor current flows. So the load current is 5. This is how IC is coming. So Thyristor current is 5 minus IC. So Thyristor turns off beta when the current becomes 0. Or you can say 5 minus, we already derived the capacitor current. 5 minus 10 sine omega t becomes 0. So sine omega naught t is 5 by 10, that is 0.5. So omega naught t is pi by 6. So time equal to 0.523 into 10 to the power minus 4, 52 microsecond. So basically, I derived the Thyristor current in terms of the load current. Why is load current 5? 100 by 20. If my SCR is conducting, SCR will be shorted. So 100 by 20, load current will be 5. So the total Thyristor current contains load current and capacitor current. When the net current becomes 0, then my Thyristor turns off. चलिए next. Circuit turn off time for a SCR is defined as the time होल्डिंग करंट का यूज नहीं करना होता सुमुखा किसी भी तरह के क्वेश्चन में. यू डोंट हैव टू यूज द होल्डिंग करंट इन SCR. ओके. और टर्न ऑफ का ग्राफ नहीं बेटा, टर्न ऑन का ही है. वोल्टेज बढ़ रहा है, वोल्टेज घट रहा है, करंट बढ़ रहा है. तो दैट इज टर्न ऑन. देखो अगर आप देखोगे ये देखो ना. हाँ एक सेकेंड, ये टर्न ऑफ है. दिस इज एक्चुअली टर्न ऑफ. वोल्टेज बढ़ रहा है, करंट घट रहा है. ये आएगा, सही बोल रहे. And you know beta, whenever one quantity decreases, increases, other is constant, we use VI by 2. For which the SCR is reverse biased by commutation circuit. Not to reduce the current below holding current. We do the reverse biasing after current goes below holding current. तो D वाला ऑप्शन गलत क्यों है? रिवर्स बायस करके करंट को नहीं घटा रहे हैं. करंट जब होल्डिंग के नीचे गया उसके बाद रिवर्स बायस करते हैं. तो आंसर इज सी. नेक्स्ट, द टिपिकल रेशियो ऑफ अ लैचिंग टू होल्डिंग करंट इन अ 20 एम्पियर थायरिस्टर. यू नो द रेशियो लाइज बिटवीन 1.3 एंड 3. तो आंसर विल बी 2. कितना रेशियो होता है? 1.3 से 3 के बीच होता है. ये वाला हम लोग कर चुके हैं ऑलरेडी, राइट. क्या है ना, स्विचेस वाले आपको जो क्वेश्चन है वो सिर्फ गेट में ही मिलेंगे. द क्वेश्चन बेस्ड ऑन स्विचेस ओनली यू विल फाइंड इन गेट PYQ. So most of them would be already done. I think we have also discussed this है ना? This also already done, right? The value of R, I think it was 6060. Correct? This also we had already done. 6060 was coming. Now try this one. This we have not done. Try this. इसको try कीजिए भाई. ठीक है भाई. Now see, a steady DC current is of 100 ampere is flowing through the power module. But see the direction of current. Current is going from the bottom to the top. So my diode will be on. And this is the second graph is the characteristic of diode. So here, based on the graph, V on is 0.7, R on is 0.01. Now power loss will be V on into I average plus IRMS square into R on. Now we know beta that current is 100 ampere, it is constant. So for constant current, average and RMS are same. So that is 170 watt. Simple. 170 watt. Average and RMS are same for constant current. चलिए ट्राई दिस वन. ये वाला किए थे क्या हम लोग? बताओ मुझे एक बारी. हैव वी ऑलरेडी डन दिस? मुझे ऐसा लग रहा है कि हम कर चुके हैं. आप लोग बताइए. ये हुआ है क्वेश्चन? बताओ जल्दी से. बख्शी जी, सुभादीप, रौनक, हैव वी डन दिस? डन है ना? चलिए. फॉर द पावर सेमीकंडक्टर डिवाइस IGBT MOSFET डायोड थायरिस्टर विच स्टेटमेंट इज ट्रू? टेल मी विच स्टेटमेंट इज करेक्ट फॉर दीज डिवाइसेस. बोलो मेरे भाई. विच स्टेटमेंट इज करेक्ट फॉर दीज डिवाइसेस? Only MOSFET is the majority carrier device. Rest everything is minority carrier. Very good. चलिए ये वाला देखिए जरा. Which device can carry the current in the direction that is shown? इनमें से कौन सी ऐसी डिवाइसेस हैं जो दिखाए गए डायरेक्शन में करंट कैरी करने के काबिल हैं? Which devices can carry current in the direction shown? Thyristor, no, it is unidirectional. GTO, no. Triac, yes. MOSFET, yes. ड्यू टू बॉडी डायोड, है ना, ड्यू टू बॉडी डायोड. So reverse current triac and MOSFET can carry because they are bidirectional. अच्छा ये वाला देखो. You have to tell me at which point 1, 2, 3, 4. At which point IGBT experiences highest current stress. ठीक है, highest current stress किस point पे आएगा? So you have 4 options. The 4 points 1, 2, 3, 4. आपके 4 ऑप्शन 4 पॉइंट है बेटा यहां पे 1, 2, 3 एंड 4. देखिए भाई, देखिए, the load is highly inductive. It is saying a double pulse measurement for inductive loaded circuit controlled by IGBT is carried out to evaluate the reverse recovery characteristic of a diode. Okay, L parasitic is a parasitic inductance. It is in series. Okay. Now beta load is inductive. So I will say current is constant. Okay. Because earlier diode was carrying a constant current. Now diode is turning off. So we are seeing reverse recovery. So when IGBT is turning on, diode will be turning off. Okay. Diode will be turning off. ठीक है, तो I is constant. So you can say thyristor, switch plus diode current is I. So switch current is I minus ID. So this will be maximum when this will be minimum. Okay. So answer should be 3. 3 पे आएगा when the diode current is minimum, the switch current will automatically be maximum. चलिए, try the next one बेटा. 200 kilohertz. Which device is best suited? Which device is best suited? MOSFET. High frequency MOSFET is the best device. ये try करिए. देखिए भाई, a semiconductor switch needs to block the voltage of one polarity and conduct in both the directions. So which it can be? A. Anti-parallel diode makes the switch bidirectional and unipolar. B. No. Why? Because diode will say that current can only flow in one direction. डायोड के अनुसार करंट एक ही डायरेक्शन में जा सकता है. करेक्ट. इट कैन नॉट फ्लो टू द राइट. नाउ हियर this diode will say current can only go to the right, so it is also wrong. Here IGBT and diode will conduct to the right, but this diode, sorry, BJT and diode, this will conduct in the opposite direction. So D. So answer will be A and D. Okay, A और D आ जाएगा. चलिए next. The circuit in the figure has reached a steady state with thyristor in the off condition. Latching and holding current are 0. Thyristor is on at t equal to 0 microsecond. Duration in microsecond for which thyristor conducts before turning off. ऑफ होने के पहले कितनी देर तक कंडक्ट करेगा बताइए. I need to know the conduction time. देखें भाई, just like beta we solved one question, it is saying we have already reached a steady state with the thyristor off. देखिएगा, we solved one question based on LC oscillator na, this is similar to that. Now t equal to 0 minus SCR is off, capacitor open, inductor short. We are under steady state. So in this circuit beta, there is no current flow. So current here is 0. And the entire supply voltage appears across capacitor. Now, when thyristor turns on, so short it. And capacitor is charged to 100 volt. Okay. So this current basically will be 100 by 425. Capacitor current will be like this. So what is the thyristor current? 25 plus IC. What is IC? Capacitor is charged to 100 volt. 100 root C by L sin omega naught t. Thyristor turns off when IT is 0. Now omega naught t pi plus pi by 6, 7 pi by 6. So the time omega naught is 1 by root LC. So it will be 2. 7 pi by 3 microsecond. How much is this coming? 7.33. Okay, 7.33. Clear हुआ भाई ये? This answer is 7.33. Clear हो गया ना सभी को? बोलो जल्दी से. Is this clear to everybody? चलिए. In which of the following switching devices which is fastest? If they have similar rating, which of them will be fastest? Come on. इनमें से कौन fastest है? The answer is very obvious. Everybody knows. Power MOSFET. Very good. ये वाला हम लोगों ने कर लिया था ना? Due to source inductance. Due to source inductance, both the devices will conduct for more than 180. Ideally, they should conduct for 180. Chaliye. The question says, it is the circuit diagram of a controlled rectifier. Actually, it is a semi-controlled rectifier. 10:1 ideal transformer. Firing angle of T1, T2 is given 90 and 270. Why? It will turn on at alpha. This at 180 plus alpha. So if alpha is 90, 180 plus alpha is 270. यही होता है ना, एक डिवाइस अल्फा पे तो एक 180 प्लस अल्फा पे. I need the RMS current through the diode D3. D3 is my freewheeling diode. D3 is my freewheeling diode. क्या आएगा? Answer is 0. Why? Because the load is resistive. In resistive load, there is no freewheeling action. Resistive load में कभी कोई freewheeling action होता ही नहीं है. Very good. A phase controlled single phase full bridge converter is supplying a highly inductive DC load. It is fed from 230 volt 50 Hz AC. Fundamental frequency in Hertz for the voltage ripple on the DC side. The answer is C. Okay. It is a two-pulse converter. Single phase full bridge is two-pulse converter. So F0 is 2F in. So it will be 100. चलिए next. Input power factor. What is the input power factor in this circuit? और कोई क्वेश्चन अगर कर रखा है तो बताते चलना कि सर ये ऑलरेडी डन है, क्योंकि ये भी मुझे लग रहा है कि हम लोग कर चुके हैं. इनपुट पावर फैक्टर तो द आंसर इज 0.707. देखिए फॉर रेजिस्टिव लोड दिस इज अ हाफ वेव रेक्टिफायर. PM/2 यानी 50. PS RMS 100/√2. For resistive load, always remember this is the input power factor. Is 1/√2. ठीक है. Why is it not unity? Because of harmonics. Waveform of current drawn by a semi-converter with sinusoidal AC voltage source is shown. RMS of fundamental component. This is what? This is a quasi-square wave. I need fundamental RMS current. तो बेटा फंडामेंटल RMS is 4I0/pi divide by √2 cos θ/2. This is theta. It is going from theta to pi, so cos θ/2. (17.392 ampere). 17.392 ampere. Very good. A single phase fully controlled rectifier is supplying a load with anti-parallel diode. Which of the following is true for instantaneous load voltage and current? इनमें से क्या पोलैरिटी होगी V0 और I0 की इस कन्वर्टर के लिए? बहुत ही इजी है, बेसिक क्वेश्चन है. Answer is C. It becomes a semi-converter when you have SCR plus freewheeling diode. So it will operate in first quadrant only. ये सिर्फ फर्स्ट क्वाड्रेंट में चलेगा. ओके, चलिए ट्राई द नेक्स्ट वन. ट्राई द नेक्स्ट वन बेटा. आई नीड द वैल्यू ऑफ अल्फा. अल्फा निकालना है, बनाइए. देखें भाई, देखो V नॉट इज Vm by 2 pi 3 plus cos alpha. Now Vm is 80 pi. So it is 120 plus 40 cos alpha, which is 80 volt plus I naught R. Now the battery power is 1600, which is battery voltage into I naught. So you can say I naught is 20 ampere. Em is 80 by 120. So alpha will be 90. Because now 40 cos alpha is 0, so alpha should be 90. ये आ रहा है यार. Em is 80 pi. 80 pi by 2 pi 40. 120 plus 40 cos alpha. पावर दे रखी है बैटरी की 1600. तो करंट आया 20. 20 इंटू 2 40. 40 प्लस 80 120 आया. ये भी 120 प्लस 40 cos alpha आ रहा है. 90 आ रहा है ना. चलो ट्राई द नेक्स्ट वन. Lowest harmonic component in the AC input current. ठीक है. तो remember बेटा, in a rectifier, output side harmonic has the order NP. Input side current has the harmonic of order NP plus minus 1, where P is the pulse number. So it is talking about 6 pulse converter AC input current. So minimum order 6 into 1 minus 1, 5. Frequency of fifth harmonic is 5F, which is 250. So just remember this basic concept. You can judge the frequency of harmonic on output and the input side. Chaliye next one. Power factor I have to tell for the AC supply. Input power factor. हाँ भाई. Average voltage 180 with 10 ampere constant current. Power factor. For power factor beta, We need cos alpha, है ना? We know the power factor of a highly inductive load for a single phase full converter. Okay, input power factor is G cos alpha. G for a single phase rectifier is 0.9, 0.782. Very good everyone. तो देखो रेक्टिफायर पे छोटे छोटे ही ज्यादातर सवाल बनते हैं. ट्राई दिस बेटा. RMS value of AC line current in a fully controlled 3-phase bridge converter. Very simple. डायरेक्ट फॉर्मूला बेस्ड क्वेश्चन. बनाइए इसको. ये मेरे ख्याल से हम लोग डिस्कस किए थे क्या? And this belongs to GATE 2019, which was one of the simplest paper. So 100 root 2 by 3, 81.65. Very good. चलिए see this. See this. Full bridge diode rectifier fed from 230 volt 50 hertz sinusoidal source. Most dominant frequencies in the source current. Most dominant frequency component. I'm not asking, remember, I'm not asking the harmonic, dominant harmonic, no. Dominant frequency component. Now you know NP plus minus 1. Single phase full bridge. So 1 is the fundamental. 3. It never said that you need to tell harmonics. You just need to tell me the dominant frequency. The most dominant frequency on AC side is always fundamental. Nothing is bigger than fundamental. Now try this question. I want you to find the overlap angle mu. बनाइए. देखिए भाई, a single phase fully controlled thyristor rectifier feeds R with a large inductance from ideal 230 volt 50 hertz source. Inductance is given, alpha is given. I need to know the value of mu. Now what we can do is, I know Ls, I know the value of alpha. First of all, I will apply okay. Now 2 into 230 root 2 by pi cos 45 minus 4 into 50, 2.28 millihenry. I naught I will write as V naught by R. So from here beta I can find V naught 460 root 2 by pi cos 45. Collect the terms of V naught on one side. $140.0368. Now V naught can be written as Vm by pi cos alpha so that means cos 45 V naught is 140.0368 into pi by Vm 230 root 2 minus cos 45 cos inverse is 4.8 degree. Yes, 4.8 degree. Very good, Subhadeep. चलिए try the next one. Active power drawn by the load. You need to tell me the active power of the load. बनाइए इसको. The diodes are ideal. You have a resistive load. What is the active power of the load? Very easy question. If it is a full bridge diode rectifier, you must know the RMS output. जसवंत भाई, मैंने ये नहीं बोला L and C do not absorb any reactive power. No, I told L and C are the element that do not absorb any energy, total energy in one cycle. But we define a hypothetical power called as reactive power for the sake of analysis. Which formula we should remember? बेटा मैंने ये जो क्रैश कोर्स के लेक्चर्स हैं इसमें बताया है कौन से फॉर्मूला याद करने हैं, टेबल फॉर्म में समराइज भी कराए हैं. Because beta it is a resistive load, I need RMS value for power. ठीक है. For full rectifier, full wave, RMS value of output is same as input and power will be V naught RMS square by R. $800 watt. Simple. 800 watt. Very good, Rahul bhai. Try this, beta. This is finding the power factor in the case of harmonics. आपको हार्मोनिक्स के सिचुएशन में पावर फैक्टर बताना है. निकालिए. आया भाई? देखो, whenever you want to find the real power, consider voltage and current having the same frequency, which is omega omega, cos of phase shift 2300 1150 by root 2. Now VRMS is 230, IRMS half 10 square plus 4 square plus 3 square, 125 by root 2. Now, power factor is beta, the basic formula for power factor. This is how you have to solve the question based on power factor. So, root 2 will be cancelled beta. .447. There is one more method that you can try. Because the voltage is sinusoidal, you can say distortion factor is fundamental RMS by total RMS. Fundamental RMS is 10 by root 2. Total RMS beta we just now calculated 5 root 5, 2 by root 5. And then beta, if you see the phase shift between voltage and current, FDF is cos pi by 3. So input power factor 2 by root 5 G into cos pi by 3, 1 by root 5. But this G into FDF can only be applied when voltage is sinusoidal and we know the Fourier series of current, because then I can find the distortion factor. अगर करंट की फोरियर सीरीज मालूम है तो डिस्टॉर्शन फैक्टर आ सकता है, तभी ये मेथड लगाना. चलिए ट्राई दिस. एम्पलीट्यूड ऑफ द फंडामेंटल कंपोनेंट ऑफ सोर्स करंट. इट इज अ सेमी कन्वर्टर. ये सेमी कन्वर्टर है. फंडामेंटल कंपोनेंट का आरएमएस एम्पलीट्यूड निकालिए. $12.47. बेटा ये सेमी कन्वर्टर है. एम्पलीट्यूड 4 I naught by pi. एम्पलीट्यूड माने पीक वैल्यू. cos alpha by 2. Alpha is 45. Okay. 17.64, ठीक है, 17.64, इसको √2 से डिवाइड तो नहीं कर दिए? Everybody who is answering 12.47, they have computed RMS, and that was the exact same mistake बेटा जो बच्चों ने किया था 22 में. They confused between the RMS and the amplitude. So the answer is 17.64. चलिए, try the next one बेटा. मैंने आपको इसका एक शॉर्टकट बता रखा है. Now we have 3 thyristors, 1 diode. I have 3 thyristor, 1 diode. You need to tell me V0. I gave you a shortcut for this situation. कितना है? 39.78. So now beta, there are 3 thyristor, 1 diode. So with number of thyristor, we multiply cos alpha, and diode is kept as it is. Alpha is 60. Sir, what about 240? Beta, if one thyristor is triggered at alpha, the other will be triggered at 180 plus alpha. 39.788. बहुत बढ़िया. चलो नेक्स्ट देखिए, गेट 24 प्रॉब्लम. अ सिंगल फेस हाफ कंट्रोल्ड ब्रिज कन्वर्टर सप्लाइज इंडक्टिव लोड. अल्फा इज गिवन. RMS value of fundamental component of input current to the RMS value of total input current. Simple question beta, it is nothing but distortion factor. It is asking for single phase semi converter, the distortion factor. अब कुछ कॉन्फिडेंस आ रहा है भाई रेक्टिफायर पे, बताइए. Now are you getting the confidence that we can solve rectifier problems in gate? These are all gate problems only. ये गेट के ही क्वेश्चन है मेरे भाई. अगर ये बन रहे हैं तो गेट में भी बन जाएगा. Point 4843. Now when alpha is 60, it is a single phase converter. It will be this. 2 root 2 by pi I naught cos alpha by 2. Cos 30 is root 3 by 2. Now G. .955. Okay. अब देखो this question in just last year बेटा it was asked from the drives है ना. Even though drives is not in a gate syllabus but they still asked it. Let's see this. A single phase fully controlled thyristor converter bridge is used for regenerative braking. Now during the braking beta motor has to operate as a generator and it has to deliver the electrical power. So the rectifier has to act like an inverter and convert DC to AC. Now motor is running at 600 RPM and the terminals are suitably reversed for regenerative braking. Armature current is at the rated value, that is 10 ampere. Okay. But speed is 600. What is alpha? Now listen carefully beta. It is a separately excited DC motor, which means I can take flux to be constant. Now the rating is given beta. In the rating the speed is 1200 RPM but it is working at 600. So I need to know the EMF. So I will say at rated condition, that is when my speed is 1200 RPM. What is E1? Terminal voltage 210 minus 10 into 1. 200 volt. Okay. Now at 600 RPM, because flux is constant, so E2 by E1 it is 100 volt. Okay. Now beta, during braking, you are saying current remains the same. But for braking, for inverter, EMF polarity should reverse. मानते हो ना? EMF polarity should reverse. Now it is a single phase fully controlled bridge. Input of the bridge is 240 volt at 50 hertz. ठीक है? 240 volt at 50 hertz. So this is nothing but DC drive. So beta, even if you do not prepare the entire drive chapter, DC drive, because it just requires the basic knowledge of DC machine and basic knowledge of rectifier or chopper. That if you can, you should prepare, especially if you are targeting under 100 rank. Okay. अगर अंडर 100 का सोच के चल रहे हो भाई तो डीसी ड्राइव मत छोड़ना, कर लेना. क्वेश्चन बेसिक होते हैं. देखिए यहां तक सारा कॉन्सेप्ट मशीन का था और लास्ट के 2 स्टेप पावर इलेक्ट्रॉनिक्स. राइट. चलिए सिमिलर क्वेश्चन वी डिड बेटा. नाउ यू हैव टू फाइंड द इनपुट पावर फैक्टर. तो बात देखो KM5 निकालना इज नॉट अ गुड मेथड आई वुड से when you can make use of ratio, because if you find KM5 you will truncate it to certain number of decimal places and that is where your error creeps in. वहां पे आपका एरर आना स्टार्ट हो जाता है क्योंकि आपको अप्रोक्सीमेशन तो करना ही पड़ेगा. रेशो में देखो सीधा सीधा इंटीजर वैल्यूज मिलती हैं, है ना. तो इन डीसी मशीन एज मच एज यू कैन यूज द रेशो and where it is not possible to use the ratio, use KM5. Especially beta, KM5 we generally use when we are dealing with both torque and EMF, because for both torque and EMF that constant is same. है ना. If I want to convert torque to current, but I do not know how to do it, then from EMF I can find Km phi and use that to convert torque into current. Logic समझ रहे हो? अगर मैं EMF से और स्पीड से Km phi निकाल लूं और मुझे सवाल में टॉर्क दिया है तो मैं टॉर्क से करंट बना सकता हूं. ऐसी सिचुएशंस में वो हेल्पफुल होता है. नाउ सी दिस बेटा. अगेन माय वोल्टेज इज साइनोसॉइडल. So I will try to find G, fundamental RMS current by total RMS. What is fundamental RMS? Simply 10 by root 2. Total RMS half 10 square plus 2 square plus 1 square. So 10 by root 105. Now the phase shift between voltage and current, fundamental voltage and current is pi by 6 cos pi by 6. So input power factor is G into FDF. Okay. Point 845. See? 0.845. ठीक है. वेरी गुड सुभादीप एंड शदान. अगला देखिए बेटा. पीक ऑफ द करंट, पीक ऑफ द इंडक्टर करंट. If the SCR has alpha equal to 0, it means it is working as a diode. And beta, even in just 2025, you see 1 mark for rectifier, 2 mark, 2 mark. So total 5 mark from just one chapter of rectifier. That is how much important it is. ये इतना important है कि 4-5 नंबर का एक इकलौता चैप्टर कभी कभी आ जाता है. ठीक है. ऐसा नहीं कह रहा हूं कि 26 में भी इतना ही आएगा, हो सकता है बिल्कुल भी ना आए, बट ऐसा बेटा कभी होता नहीं है कि एक भी क्वेश्चन रेक्टिफायर से ना आए. यू कैन एक्सपेक्ट एटलीस्ट 2 मार्क्स एंड अ मैक्सिमम ऑफ 5-6 मार्क्स फ्रॉम रेक्टिफायर. So that is why rectifier is very important. Just learning one chapter can fetch you so many marks. और अगर आप क्वेश्चंस देखोगे बहुत बेसिक होते हैं बेटा. Now beta, IL max occurs at omega t equal to pi where voltage changes sign. ये मैंने आपको समझाया था ना. जब वोल्टेज पॉजिटिव से नेगेटिव जाती है तो वहां पे करंट का मैक्सिमा आता है. तो नाउ आई विल से L di by dt is 230 root 2 sin omega t. Now you are starting at alpha equal to 0 where current is 0. Up to 180 you will reach peak current. So IP will be 460 root 2 by omega L. Now somebody who might have memorized the diode equation, they can also easily solve it beta. L is 100 millihenry, 0.1 Henry, 10 pi, 46 into root 2 by pi. Actually, it will be 20.7. मैं बिना कैलकुलेटर के भी बता सकता हूं. हाउ? I know 2 root 2 by pi is 0.9. So I can write 23 into 2 root 2 by pi. I will write 23 into 0.9, which is 20.7. है ना? और somebody diode plus inductor, if you remember, the equation was this. So maximum is 2 Vm by omega L. But just remember the basic beta. मैक्सिमम करंट ऑफ अ इंडक्टर ऑकर्स व्हेनेवर इंडक्टर वोल्टेज चेंजेस साइन। ये बेसिक याद रखिए। चलिए इस सेशन का आखिरी क्वेश्चन, अल्फा फायरिंग एंगल है, पावर दे रखा है रजिस्टर का, आपको अल्फा बताना है। करिए, यू नीड टू टेल मी द वैल्यू ऑफ अल्फा। और देखो हमेशा मत याद रखना कि 2Vm/ओमेगा L ही होता है हमेशा, नॉट ऑलवेज बेटा। इट विल ओनली बी व्हेन डायोड इज कनेक्टेड टू अ इंडक्टर, इट इज नॉट ऑलवेज ट्रू। Now beta, until they give you beta, you have to assume highly inductive load. So you have to say that I naught is constant. So I naught will be 8. For average voltage beta, inductor does not matter. So see beta, how easy was this question? How basic was it? Now gate people are having so low expectations that they are even giving you the formula for V naught. आप लोगों से इतनी उम्मीदें उन्होंने कम कर ली हैं, कह रहे हैं वी नॉट भी लिख के दे रहे हैं। भाई अब तो बना दो रेक्टिफायर का सवाल, ठीक है, तुम्हें वी नॉट भी नहीं निकालना, वो भी हम बता ही दे रहे हैं, बस फॉर्मूले में पुट कर दो वैल्यू। तो दिस क्वेश्चन, दिस सिंपल क्वेश्चन वाज फॉर 2 मार्क्स। चलिए, नाउ लेट्स डिस्कस वन असाइनमेंट टुडे, लेक्चर 6। फुल कन्वर्टर इज फीडिंग अ RLE लोड, L is large enough, what is the input power factor? If inductance is large enough beta, you just use the same formula as a RL load. A. Answer will be A. Single phase full bridge rectifier with freewheeling diode, load resistance, large inductance, supply alpha, average thyristor current. Now beta, it becomes a semi-converter whenever a full converter has a freewheeling diode, it becomes semi-converter. So thyristor conduction angle becomes pi minus alpha, which is 2 pi by 3, because alpha is pi by 3. ठीक है? Now beta, V naught. So I need to find I naught beta. For that I am finding V naught. Cos pi by 3 is 0.5. So 1.5. 155.3 volt. MP. So it will be 3.33. चलो सुमुखा भाई, बहुत बढ़िया, अगर मेहनत की हो। अब आंसर भी बताते चलो इस असाइनमेंट के। पावर डिसिपेटेड इन द लोड रेजिस्टेंस आर Now, because alpha is not given, it is saying diode bridge rectifier. In diode bridge rectifier, V naught RMS is same as Vs RMS, which is 230 by root 2. It is a resistive load, therefore beta I am focusing on RMS. रेजिस्टिव लोड है इसीलिए आरएमएस पे फोकस कर रहा हूं. तो आंसर इज डी. ठीक है, आंसर इज डी. बोलो भाई, असाइनमेंट के आंसर्स बोलते चलो. A fully controlled bridge converter feeds a highly inductive load. Vs is a sinusoidal source. Input power factor. So it will be 0.78. Same data है जो क्वेश्चन 1 में था. A separate single phase fully controlled bridge is used for electrical braking. DC motor load is represented by this. I naught is this. Now, if you see beta, for braking, power should go from DC to AC, so the battery is connected with reverse polarity. बैटरी रिवर्स पोलैरिटी के साथ कनेक्टेड है. -130. So now 2 Vm, Vm is 460 root 2. So alpha, how much is alpha coming? Definitely it has to be greater than 90, because here the rectifier is acting as an inverter. It is 128.88. 129 degree. Full bridge converter is supplying RLE load. Vm is given. Real power fed back to the source. -800 plus I naught into 1. So I naught will be 600 ampere. Power going to the source will be V naught I naught 200 into 600, 120 kilowatt. यही आ रहा है 120 kilowatt. Okay. Single phase converter bridge is used to charge a battery. SCR is triggered by a constant DC signal. That means it works as a diode. Now SCR2 is open. Do not say that SCR1 has to continuously conduct. There is no inductor. So SCR1 does not have to be permanently on. मैंने आपको सिखाया था ना, एक SCR ओपन हो जाता है तो उसका जो भाई बंधु है वो परमानेंट ऑन हो जाता है. वैसा यहां नहीं होगा. ठीक है, वैसा यहां कुछ भी नहीं होने वाला है, बिकॉज देयर इज अ RE लोड. So what we have to do? We have to find the value of theta. Okay. So theta sin inverse E by Vm 200 by 230 root 2. I need the average charging current beta. 37.9428. Now for the average charging current मेरे बच्चों, it will now start to behave as a half wave rectifier, because only one group of thyristors is going to conduct. दूसरे वाले ग्रुप में से एक तो उड़ गया. करेक्ट. So only one group can conduct. Two Vm cos theta. Now what is the resistance? Resistance is how much? 2 ohm. Cos 37.94. 200-volt battery. $11.9. ठीक है, 11.9 की ऑप्शन है भाई. चलो बहुत बढ़िया. Semi-converter is operated from a source. Resistive load is connected at the DC terminal. Average output is 25%. Alpha, average and RMS load current. It is 25% of maximum average. Now this maximum average occurs at alpha equal to 0. ठीक है? So 1 plus cos alpha is 0.5. So alpha is 120. Now, this is my average output by R. (120 √2). 60 into 2 √2, 54.54. Okay. Now what about V0 RMS? I will integrate from 120 to 180. M square sine square omega t. Sine square is 1 minus cos 2 omega t by 2. So integration of 1 will be 60 degree or pi by 3. Cos 2 omega t is half sine 2 omega t. ठीक है? Cos 2 omega t is half sine 2 omega t, which will be 0 at 180 because sine 360 is 0. So pi by 3 plus 0.5 sine 240 divided by 2 pi under root answer to 240 into root 106.11. Okay. So I naught RMS (1.0). 1.06. ये आ रहा है, कुछ और आ रहा है. ये आ रहा है यार. Semi-converter is connected to supply. IS is continuous and ripple free. Harmonic factor basically is THD. It will be cos pi by 4. Cos alpha is pi by 2. Alpha is pi by 2. So G (2 √2 by pi). Based on this beta, THD is 48.34%. That is your harmonic factor 48.34%. यही दे रखा है. हाँ जी. A single phase controlled rectifier bridge contains one SCR, 3 diodes. ठीक है. So V naught will be Vm by 2 pi. There is one SCR and 3 diodes. So it will be 230 root 2 by 2 pi 3 plus cos 45. 191.91. ठीक है. Power, for that we need I naught. P naught minus E by R. $18.382. Battery power is EI naught. Answer will be B. Average output voltage is 5 volt. What is the value of LS? So this is a 1 pulse converter. ठीक है. यहाँ पे अल्फा 0 लिया बिकॉज ऑफ डायोड. ओमेगा इज 8. बट यहाँ पे म्यू 1 plus cos alpha now alpha is 0. F is omega by 2 pi. I naught is 4 ampere. So what is LS? 10 pi. 10 pi. 40 minus 10 pi divided by 32.268. 0.268 हेनरी. यही आ रहा है 0.268 हेनरी. बताइए. दिस इज व्हाट यू आर गेटिंग. 10 का V नॉट का ग्राफ एक बार. तो बेटा फ्रॉम 0 to alpha because thyristor 1 does not turn on. So basically D3 has to conduct. So output will be 0. Then alpha to pi D1 D1 and then pi to 2 pi D2 D3 like this. And here until T1 turns on D3 D1. That is why you get a freewheeling action. ठीक है बख्शी जी. If diode D2 fails to work, change in average output voltage. Open. So that means this will be always on. Okay. Just a minute, beta. Just a minute. We will discuss this. सर इसमें फ्री व्हीलिंग नहीं होगा आफ्टर पाई फ्रॉम वन लेग। फ्री व्हीलिंग क्यों होगा पाई के बाद भाई? बाकी दो डायोड्स कंडक्ट कर देंगे ना बख्शी जी। फ्री व्हीलिंग तो तब आता है बेटा जब करंट के लिए कोई रास्ता ना बचे। दो डायोड्स पाई से 2 पाई कंडक्ट तो कर सकते हैं, तो फ्री व्हीलिंग किस बात का? ठीक है, आइए देखें। तो दिस इज ओपन, दिस विल बी ऑलवेज ऑन। नाउ आइडियली, ठीक है, if we talk about without ls, D1 will be on from 0 to pi, D3 from pi to 2 pi. When D1, D4 are on, V0 is 0, V0 will be minus Vs. But at pi beta, at pi and at 0 degree, there will be overlap. ठीक है, at 0 degree and pi, there will be overlap beta. Overlap occurs. Okay. So now during overlap, V0 will be 0. Now 0 to mu, V0 will be 0. Okay. So V0 average integration of sign will be minus cos. Okay. This is average output. Now, this is the, but I do not know what is V0. यहाँ पे म्यू नहीं मालूम। तो बेटा if D2 is fine, V0 is 2 Vm by pi minus 4 FLS I0. Four into F is 8 upon 2 pi (10.6952). ठीक है, कॉन्टिन्यूस कंडक्शन है तो वी एवरेज में ई का कोई रोल नहीं होगा बख्शी जी। 10.6952। ठीक है, ये आ गया अपने पास पहला V0। Now, if I can keep the same overlap angle, (10.6952) is Vm by pi 1 plus cos mu. Okay. Not 1 by 2. तो परसेंटेज चेंज इज 50%. आधा रह गया ना एक डायोड के ओपन होने से. ठीक है, आधा रह गया भाई. फिफ्टी परसेंट आना चाहिए. आंसर किस फॉर्मेट में दिया है? चेक वन. चेंज शुड बी 50%. ये आना चाहिए यार. चलो, ड्यू टू D2 ओपनिंग. ये देखना जरा, वैल्यू ऑफ पावर एब्सॉर्ब बाय करंट सोर्स. यू नीड टू फाइंड V नॉट I नॉट. You need to find V naught I naught. Okay. So it is a 2-pulse converter, 2 Vm by pi minus 4 FLS I naught. So 2 into 40 by pi minus 4 into F 4 by 2 pi LS I naught. So 80 by pi minus 16, 64, 128, 64 by pi. 16 by pi. So power is V naught I naught 20.37. ठीक है, यही दे रखा आंसर 20.37. अच्छा, यहाँ पे ना एक चीज और है. So this will become a 1-pulse converter. अगर ये 1-pulse converter की तरह बिहेव कर रहा है बेटा, तो what you can say, V naught is Vm by 2 pi या फिर Vm by pi minus FLS I naught. So Vm by pi will be 20 by pi minus F is 8 upon 2 pi. LS is how much? आप म्यू को सेम मत मानिए. म्यू कैन चेंज इन बोथ द सिचुएशंस. म्यू हो सकता है चेंज हो जाए. 16 1.6 by pi, 32 3.2, 5.857. Change. Okay. 10.6952 is 4.8382. In both the cases, the change is 4.8382. Inductance is very large such that load current is constant, power is 200 watt. What is the value of I naught? Two hundred divided by 100 upon pi, 6.28. It will be 2 pi. Power absorbed by the electric circuit. Vt is given, It is given. नाउ बेटा वैसे तो देखो इसका पावर इलेक्ट्रॉनिक्स से कोई लेना देना नहीं है, ठीक है. सो दिस यू कैन स्किप. लेट मी टेल यू द मेथड. मेथड मैं बता देता हूं, ठीक है. यू हैव टू सॉल्व वन बाय वन फॉर डीसी. ओके. E1. Inductor will be short. So V1 will be equal to V, that is 20. For omega equal to 2. V1. The voltage is 8 cos 2t into R by R plus j omega L. Okay. So 8 by root 2 angle minus 45. 8 by root 2 cos 2t minus 45 और 8 by root 2 sin 2t plus 45. Omega equal to 3. V1 will be 10 into resistance is 4. 4 plus j6. 40 by 4 plus iota into 6. 5.547 minus 56.3. Okay. Now, beta, when finding the power, there is no DC current. For 2T, current has an angle 6 sin 30, 6 at an angle 30. Angle is 30 for current, 45 for voltage. For sin 3T, 5 by root 2, 5.547 by root 2. Angle of current is 30, voltage is minus 56.3. Okay, like this. ये हो जाएगा. समझ में आया लॉजिक? तो आपको एक एक फ्रीक्वेंसी के लिए सर्किट का वोल्टेज निकालना होगा. नाउ एवरेज वैल्यू ऑफ आई नॉट. V naught is Vm by pi. ठीक है. So it will be 20 by pi. So I naught will be V naught by R. Because after pi your freewheeling diode will start to conduct. So power V naught I naught 100 by pi square 10.132. Okay. 10.132 watt. Shunt motor takes armature current 4 ampere, runs at 1200 rpm on no load. Armature resistance 0.2, shunt resistance 200 ohm, 5 kilowatt is applied. Armature current drawn is 20 ampere. तो V ले लो, 4 एम्पियर एट नो लोड. Now the load is 5 kilowatt at the shaft of the motor. I am ignoring the rotational loss, beta. It is a diode rectifier. So VM 254 into pi by 2, 398.98. बट यार आपको नो लोड करंट भी तो दे रखा है, रुको. Okay. Now P developed is shaft कहाँ से V निकलेगा एक्चुअली. तो 20V minus 80, 5000 minus 3.2 plus 80. तो V आया. Beta, you have to add rotational loss. You cannot ignore them because no load current is given. Four 98.4 volt. ठीक है. Now maximum value of I naught T. Okay. Maximum value of I naught T if L equal to 1 Henry. So now it is EMF is 5 volt. So this will be 1 by 2. 1 plus 2 by 2, 3 by 2. Midpoint पे आएगा ना 5 volt. Now during this part, beta, here D1, D2 on. Inductor starts to charge. And what will be the inductor voltage, beta? Input minus E. Now till the time input is more than E, the inductor will charge. ठीक है. जब तक इनपुट आपका E से बड़ा है तब तक इंडक्टर चार्ज करेगा. And it will charge from zero current to the peak current. So basically, peak current will be 1 by 1 Henry. समझ में आ रहा है? Because if the inductor voltage is positive, then only inductor can charge. Now, what is the area of this triangle? This is V in minus E. ये वाला triangle. The width is what? 1. The height is 1. Height is 5 actually. 2.5 amp. Logic समझिए. Inductor only charges till the input is greater than 0. inductor voltage greater than 0. Average output voltage, okay? You have to talk about the average output voltage. So, average output voltage will be 5 volt because inductor average is 0. इंडक्टर का एवरेज तो 0 ही आता है ना, तो एवरेज आउटपुट वोल्टेज आपका कितना आएगा? ईएमएफ के बराबर 5 वोल्ट ऑलवेज. लॉजिक समझ में आया? इट विल बी 5 वोल्ट बिकॉज इंडक्टर एवरेज इज 0. क्लियर टू एवरीबडी? 2.5 एम्पियर एंड 5 वोल्ट. So that's it, beta. That's it for today. Today there is no assignment. Now I will tell you. Now I will meet you tomorrow and I will teach you step down chopper and the buck converter. लेक्चर 8 का पीडीएफ अपलोड नहीं हुआ है, चलो मैं देख लेता हूँ. ठीक है, चलिए तो कल मिलते हैं. कल हम लोग स्टेप डाउन चॉपर और बक कन्वर्टर कवर करेंगे. ओके, इज दैट क्लियर टू एवरीवन? और YouTube वाले बच्चों के लिए बेटा मैं बता दूं कि जो 70% ऑफ आपको RIB पे और गेट 26 के लाइव और कॉम्प्रिहेंसिव कोर्सेज पे मिल रहा है, वो एक्सटेंड हो गया है टिल 30th ऑफ नवंबर. आपको YT 70 कोड लगाना है और परचेज करना है. टेस्ट सीरीज पे भी 70% ऑफ